In this video, I'm going to discuss back titration. I'm your usual teacher, Admit Shoe. So back titration involves two different reactions, which occurs when the first reaction leaves an excess reactant. The second reaction then involves the reaction of the excess reactant with the standardized reagent. So, for example, we have two slices. They require one cheese to give us one sandwich. So for example, let's say we have this setup like this one. Okay, so we don't know how many slices we have, but we know the number of cheese we have. So in this case we have got 6 cheese. So they react with unknown slices to give us the products. We don't know the quantity of sandwich you are going to form, but what we know is we are going to have unreacted cheese. So this unreacted cheese, we will find another reaction. So for example, we are going in the next reaction, the second reaction, we are going to find kids, and each kid is going to eat one cheese. Therefore, the number of kids fed is equal to the number of cheese left. Therefore, the cheese used to make the sandwich. So we want to calculate how many cheese have been used when we reacted the cheese with the slices of bread. So the cheese used to make the sandwich is equal to the initial, which is known cheese, which was 6, minus the remainder. The remainder is the quantity of cheese which was eaten by the kids. So the number of cheese the number of cheese eaten by the kids is equal to the remainder, the cheese which left after reacting. So that's our leftover. Then after getting that, we can use the relationship this relationship after getting the quantity of cheese reacted in the initial reaction. So the relationship to calculate the slices of bread used. So like here, one cheese, we know one cheese require 2 slices of bread. So we can use the relationship now to calculate the quantity of bread used in the first reaction. So like in this case, it might confuse, but remember our solutions are colorless and we cannot see the atoms or molecules. So for example, let's say we have chemicals, like here we have 4 moles of nitrogen, but we don't know the quantity of hydrogen. So after reacting, we are going to have excess nitrogen remaining, the leftover of nitrogen. Then we will find another reaction which reacts with nitrogen, so that we can quantify the amount of nitrogen remain after the reaction. Then to find the quantity of nitrogen reacted in the first reaction, we can find another reaction. Then that reaction, after getting the quantity of nitrogen reacted, then we can relate to find the amount of hydrogen reacted. So in the next stage, we are going to perform back titration simulation using the ChemLab simulator to determine the concentration of the monoprotic acid HA in the conical flask and with 0.1 molar, 50 cubic centimeters of 0.1 molar sodium hydroxide. Then in the burette there is 0.1 molar hydrochloric acid. So the first step, I'm going to mix then I'm going to carry out titration using phenolphthalein indicator. I'm going to add 3 drops. So sodium hydroxide is in excess, hence the color is pink, and I'm going to stir. So I'm starting volume 0, then I want to perform titration until I get a color. I will stop it when I get a colorless solution. Okay, now the end volume is 22,80. So the volume used is 22,8. So using this data, we are going to carry out the calculation.